So welcome to another segment as we continue on metals. So our discussion still focuses on what we are calling as being alloys. But this time now, I want to show you the structure of an alloy. So how does an alloy look like? So in an exam, they're going to tell you to draw the structure of an alloy. So you can draw the structure of an alloy in this way. So it has got foreign, particles, other, foreign, particles that are going to be there. So you can draw, when you're drawing, you can draw the bigger ones and you can also draw, the smaller ones. That is what you need to do. All right. So make them as close as possible when you're actually drawing them. So this is the way an alloy may actually, appear. So it may actually appear like this. That is what you need to remember. So for example, these are representing maybe, non-metals. The bigger ones are representing non-metals. Then the smaller ones are representing, the metal. So you can have the metal. The non-metal is representing what we can call as being the foreign atoms that have actually, come in. So that's the way you represent the structure of an alloy. But what about, the structure? Maybe we can say the structure of a pure metal. So a pure metal has got all the atoms, of the same type. So when you draw them, and wonder the atoms are capable of sliding over, each other. For example, if maybe I can draw the atoms are almost of the same size, that is what you need to remember. So they are of almost the same size. So they are almost of the same size. So you can draw it like that. And basically, the atoms are able to slide over each other because they are actually of the same size. So that is what we mean. So in there, you find that the atoms of, the same size in a pure metal. No wonder a pure metal, like we said, is actually, soft because the atoms are of the same size and they are able to slide over each other. But when you look at an alloy, you find that, atoms of different sizes. So you are going to find that there are other foreign atoms that have come in the pure metal. You put in other foreign atoms. In this case, I'm calling them as being maybe non-metals, or you can use another metal. So that creates what we are calling as being an alloy. So no wonder alloys are actually much stronger as compared to pure metal. So let's look at those differences between, an alloy and a pure metal. So we are just trying to make a comparison. So in this case, I can simply say comparison. If you want, you can say differences. Comparison, between a pure metal. So comparison between a pure metal and an alloy. So sometimes in the exam when they tell you what are the differences between a pure metal and an alloy, well, you can actually give these ones that I'm about to give you. So this side I'm going to say maybe a pure metal, and this side I'm going to say an alloy. So that what is the difference that is existing between, these two. So one, you need to remember that pure metals, they are usually soft. So that is what we can say. They are usually, soft. So they are very soft. But what about an alloy? We can say they are strong and hard. That is what you need to remember. So alloys are strong and hard as compared to pure metals from which they are taken from. In this case, they are simply going to be soft. Another comparison or difference that we can talk about is that, pure metals, they can easily be bent. So you can actually bend them very easily. So that is what we mean. So they can easily be bent. But what about an alloy? We can say they are hard, to bend. So yeah, so they are hard. So they can easily be bent, but they're hard to bend. That is what we mean when we talk about that. Another, difference that is going to be there is that when we talk about a pure metal, remember the atoms can slide over each other because they are of the same size. So we can say the atoms can slide over each other. The atoms can slide over each other because they are of the same size. That is what we mean. All right. Then what about in terms of an alloy? Well, the atoms do not slide over each other. So we can say the atoms do not, slide over each other easily because of the foreign atoms which are of different size. In other words, because of those foreign atoms, they actually disrupt the shape. They actually disrupt the shape of an alloy. No wonder when we drew them, remember we had smaller ones, we had larger ones. That's the way we actually drew them, and that's the way you are supposed to draw them when you have actually been asked to, and you label them in this case. So they can be surrounded by those smaller ones. They will be there, but you are going to have the other foreign particles. So that's an alloy. But for a pure metal, remember a pure metal is simply going to have atoms of the same size. So that is what you need to remember. That's the difference that is there. All right, thank you so much for watching this segment. So please watch out as we start looking at now extraction of metals. Watch out for that as we start looking at extraction of metals.